We are in 5.2a, graphing quadratics in standard form. Remember the difference between algebra 1 and algebra 2 is for us in algebra 1, you spend a lot of time using the calculator, right? A lot of time, unfortunately. In algebra 2, we're lessening that, okay? You are the calculator. And so today we're going to be graphing by hand and analyzing the graph. Cool?
Yes, ma'am.
All right. So things that we need to recall. So before we left for winter break, we talked about the quadratic function in standard form, which is f of x equals ax squared plus bx plus c, right? From standard form, there are things that we can learn. So in standard form, we can find the axis of symmetry, the x coordinate, the y coordinate, the y-intercept. However, it's not super duper straightforward. To find the axis of symmetry, there is a formula for it. So there's your formula to find the axis of symmetry. Remember, the axis of symmetry is when you have a parabola. It's the invisible line that divides it into two equal halves. And the equation for that is this guy. Okay? On your axis of symmetry, that's where your vertex lies. That's why when you find the axis of symmetry, you're finding the x coordinate of your vertex. There's nothing. Okay, so then once you have the x, you can then find the y coordinate by substituting that value in. Okay, lastly, your standard form also tells you your y-intercept. Your y-intercept is whatever your c value is, 0, c. Okay, so steps to graphing. These are the 4 steps that we're going to follow to graph and analyze the function. So first, we're going to find the axis of symmetry. Second, we're going to find the vertex. Third, we're going to find the y-intercept. And then fourth, we're going to graph the vertex, the y-intercept, and reflect over the axis of symmetry. 4 easy steps, and wham, bam, thank you, ma'am, we're done. Okay? So here we go. We're going to start here. We have, what is the graph of f of x equals 2x squared minus 8x plus 5? And then we're going to analyze the domain and range. Okay? So when I look here, from here, I know that a equals what? Before I start, I should be able to tell me what A, B, and C are. What's A? 2. What's B? -8. And what's C? 5. Do we all see where those numbers are coming from? All right, so now we're going to go through our 4 steps. So the first step is to find the axis of symmetry. Okay, our axis of symmetry is x equals -b divided by 2 times A. I know what those values are, so I'm going to substitute them in. So negative, instead of b, it's -8. Instead of just a, it is 2. A negative times a negative is a positive. 2 times 2 is 4. And 8 divided by 4 equals 2. So my axis of symmetry is at 2. How do we feel? Okay. Step 2 is to find our vertex. Because we know that our vertex lies on our axis of symmetry, we know that x equals 2. So your first part of your vertex is your x, and your x equals 2. If you know your x, then you can find your y. Does that make sense? So we're going to be using f of x equals 2x squared minus 8x plus 5. But instead of x, we're using 2. And everywhere that there's an x, we're going to put a 2. So we have 2 times 2 squared minus 8 times 2 plus 5. And what this is going to do is going to tell me what is my y value of my vertex. So I follow PEMDAS, right? This is where PEMDAS comes into play. PEMDAS says to do my exponent first. So we have 2 times 4 minus 16 plus 5. 2 times 4 is 8 minus 16 is -8 plus 5 is -3. So therefore my vertex is at 2 and -3. Questions about finding the vertex? Okay, step 3 is to find your y-intercept. And your y-intercept is just equal to your c value. What is our c value? 5. So our y-intercept is at 0, 5. Questions about identifying the y-intercept? The last and final step is to actually do the graph. So the first thing you graph is your axis of symmetry. Our axis of symmetry is our dashed line at x equal 2. Next, we're going to graph our vertex. Our vertex is where? 2, -3. Next, we're going to graph our y-intercept, which is at 0, 5. And then we're going to reflect our y-intercept over our axis of symmetry to get our third point. Linear equations, you need 2 points. Quadratic equations, you need at least 3 points. Do I have 3 points to create a quadratic? Yes. So here's my quadratic. Okay. Now I'm going to analyze it. What is the domain of all quadratics? What is the domain of all quadratics? -infinity to +infinity, because it goes forever to the left and forever to the right, right? It's all real numbers. Okay, all real numbers count. The range is what changes. So the range here depends on your y value. Well, I have a minimum, right? Because I have a minimum vertex, that means my y values are getting larger. So y has to be greater than or equal to my minimum. And what is my minimum? -3. So my range is y is greater than or equal to -3. It also can be written in interval notation from -3 to infinity. But you, at this point, you need to be able to toggle between both. Okay.
Yep.
How do we feel?
Good.
It's doable, right?
Yeah.
All right. So practice 1, I want you to work on in your groups. So I want you to ask your peers before you ask me for help. Okay.
All right, guys.
So practice 1 from beginning to end. I want you to ask yourselves first. I'm going to give you about 3 minutes. Okay. So 3 minutes to do the whole thing, and then we're going to come back together. All right. Whole practice 1 from beginning to end, just with your peers. If all of your peers are stuck, then call upon me.
A is -3. Oh gosh. B is 6.
So welcome back. Let's see how you did. So your A, -3, right? Your B should have been 6, and your C should have been -9. So we're going to first start off by finding our axis of symmetry. So our axis of symmetry is x equals -b divided by 2a. So that gives us -6 divided by 2 times -3. That gives us -6 over -6, which equals +1. How do we do on the axis of symmetry? Okay. Step 2 was to find the vertex. We know x equals 1. So we're going to substitute in 1 to find our y. So we have -3 times 1 squared plus 6 times 1 minus 9. That gives us -3 plus 6 minus 9, which equals 3 minus 9, which equals -6. So our vertex is at 1, -6. 3, last but not least, is our y-intercept, which equals 0, -9. Remember, your y-intercept is your c value. So now we're going to graph it all. So we have our y-intercept our y-axis at 1. We have our vertex at 1, -6. We have our axis, our y-axis at 0, -9, and we're going to reflect it. And so you should have had a little tiny parabola at the bottom. What is the domain of this parabola? All real numbers. For every single parabola, the domain is all real numbers. What is the range? Perfect. You did it. Y is less than or equal to -6. And that's because you had a maximum this time, right? And if I have a maximum value, that means that everything else has to be less than. Okay, in set notation, in interval notation, it would be from -infinity to -6. It goes the other way. You always start from the bottom and work your way to the top. It's the R. Mhm. All right. If you made an error, do you see your error?
Yes.
Did you correct it?
Yes, ma'am, we did.
All right. So practice 2, completely solo. Completely solo. No help from anyone. Practice 2 is completely solo. Here we go. So step 1, you should have found your axis of symmetry. And your axis of symmetry is x equals -b divided by 2 times a. A negative times a negative is a positive. 2 times 2 is 4. So your x equals 2. Okay. So then your vertex, x equals 2. So we're going to substitute in 2 to find our y. So we have 2 times 2 squared minus 8 times 2 plus 1. That gives us 2 times 4 minus 16 plus 1, which equals 8 minus 16 plus 1. So we have -8 plus 1, which equals -7. So my vertex is at 2, -7. Okay, my y-intercept is based off of my c value, right? And my c value is 1. So when I put it all together, we have our axis of symmetry at 2, our vertex at 2, our y-intercept is at 0, 1, and I reflect it. So I'm 2 from the axis, 2 from the axis. And here is our perfectly pretending very strongly that that's perfectly drawn. And your domain is going to always be what? All real numbers. And in this case, I have a minimum vertex. So what is my range? Greater than or equal to. Or it can be written from -7 to infinity. What's the verdict? Yay, nay, doable?
Yay.
All right, so I was trying to leave you the last 15 minutes to start on your classwork.
Where is it at?